Yes. Um, Good evening, everyone. I would like to welcome Mr. Ramesh Ramanathan, one of our fellow alumni from the batch of 2000 computer science. And he is a leading professional in the technology of software centric telecom networks driven by SDN and NFV on the cloud. And he's going to talk a lot more about it. And as the principal architect at Tata Elxsi, Ramesh oversees platforms and solutions in network orchestration and automation. By the way, can you all hear me? Kausalya, are you
Yes,
able
sir.
to hear me?
Yes, yes,
Okay,
we
okay,
can.
good. Okay. And Ramesh plays a pivotal role as a member of the technical steering committee for open source Mono and contributes significantly to ETSI standards as well. Ramesh is very passionate and dedicated to advancing autonomous networks, aiming to revolutionize operators into business intelligence driven networks with innovative revenue models. That's his passion. So please join me in welcoming Ramesh Ramanathan. Ramesh, the floor is all yours.
Thank you, Elango. Thanks a lot. Good evening, everybody. So welcome all to this presentation. I have structured this presentation into two halves, considering that and it's probably largely on a student crowd. So I want you to get the background. The first half, two different presentations. The first half, I'll give you a quick background and overview of the technology that is revolutionizing the telco space, right? So by telco, what do we mean? We mean your Geos and Airtels and Ideas, your telecom mobile operators worldwide. It is going through a complete transformation. So we look into why it's going through a transformation, what is the technology that drives it. So, with that quick background, we will get into how we can use this technology to build new age societies, right? How this technology empowers for digital equality, the kind of opportunity it gives in for entrepreneurship, wealth distribution, etc. And finally, we'll conclude by talking about how you can contribute to this journey because uh, I'm very strong on open source. I'm a technical steering committee member in open source programs. So it's a fantastic open source is a fantastic way to learn technology, build your profile, and get into the stream of things. So I'll conclude by talking about how you can contribute to this journey and mission. So, with this quick overview, let me go ahead and share my screen. So, like I said, the first presentation is going to be a context setting presentation where I'm going to talk about. I talked about the telecom networks going through a complete transformation, right? So, why and what, right? So, that's what we're going to look into. So first, let's look at a hypothetical telecom operator. You can think of it as Geo, Airtel, or if it's United States, Vodafone, whatever, right? AT&T, Verizon. So the problem with operators is so what? So you're also customers and consumers of operators, right? So what do you buy? You always buy just one product, right? Voice and data. You probably have a prepaid plan, a postpaid plan, in which you buy voice and data from the operator. But just to service you for these two products, which also comes bundled as one offering and also not very expensive, right? Due to competition, cutthroat competition, we are talking about 200, 300 rupees, and you get almost unlimited voice and data, right? Or at least good enough voice and data. But to offer you this, as the technology progresses from 2G, 3G, 4G, 5G, operators are spending thousands of crores. For example, my team is doing the rollout for BSNL for the new 4G. Overall, the program cost is around 20,000 crores. And after spending 20,000 crores, what are they going to sell to you? Same voice and data, right? So imagine a supermarket which every 6 7 years has to spend tens of thousands of crores to upgrade itself, but still offers you the same product, the two only two products, voice and data. The two comes bundled together, right? It's unimaginable in the physical world, right? But that's what operators are going through. Over and above the government regulations, taxes. So this is what the telecom operators are going through. Lot of spends, but unfortunately, very few products to sell. Really, it's the same product from one transition of technology to the other. But parking that, let's go to the customer side. Customers want new age services, right? Customers are people like you and me. You know, if it's at the right price and if it makes sense, we are willing to pay for IoT, smart homes, AR, VR, the gaming, variety of applications, as long as it, very diverse customer interests are building up, right? In fact, if you really think about it, all the verticals are kind of merging into one vertical called digital, right? So when you pick up your phone as a customer, you can either open up Amazon, you can open up Instagram, you can open up a gaming application. So what does that mean? We live in a world today where a shopping portal, social media web, app, and a gaming app, which typically you would think of it as different business verticals are all competing with one another because your time is a constant, right? So in this digital world there are a lot of not even though there's a lot of competition, this digital unified digital world gives you a lot of new possibilities for services that customers are interested. So now we are seeing kind of what do you call, the disconnect, right? Because in the previous slide we talked about operators spending tens of thousands of crores, but they are just having voice and data. But in the next slide we're talking about the digital evolution where customers can offer multiple different services. So customers can are willing to look into multiple different services. So where is the disconnect? When the customer interest is there, why operators are still only selling voice and data, right? The reason is because the traditional networks have a lot of challenges. The traditional networks are based upon embedded devices, embedded hardware, very difficult to modify, vendor lock systems, very rigid, inflexible systems. So what are embedded devices, right? So I'll give you a simple example. If you have Airtel DTH, right? That's an example, or Airtel DTH box. That's an example of an embedded device where the hardware and software is a singular unit. So this is how the entire operator network is built. So, for example, just take your day-to-day life, right? You have Airtel DTH. Let's say you want to get Geo. Can you use the same box to have Geo where you just swap in and swap out a card? No, you got to get rid of the box, invest again in a new geo box, and only you can get the geo services. That's what is called as vendor lock-in, right? So operators suffer from such vendor lock-in from large companies like Nokia's and Ericsson's, where they're tied into inflexible embedded networks where proprietary hardware, proprietary software, where they're unable to make the required changes to bring in the new services, right? So this is what the bane. So this issue is both in the software that runs as well as in the network that connects it all together, right? So both when you talk about 4G or 5G, as you can imagine, there will be a lot of software that runs it, and all the software has to be networked together, right? So that's why you're able to, for example, browse from your mobile, go to the internet, and get some data. So both the network and the software that governs the network are very inflexible, vendor locked in, and hard to modify to create the new age services. Why is it important to modify? Because even though there's consumer interest, if you look at these new age applications, they all have certain network requirements. If you take video on demand, we're talking about bandwidth. If you talk about gaming or remote surgery, we're talking about latency, right? So I should be able to modify my network real time for all these applications, which operators are not able to do because of the hardware and software that they have. And this is what gave birth to this revolution called SDN and NFV, the two technologies which, as college students, I highly encourage you to take some course in Udemy or whatever platforms that you can subscribe to SDN and NFE. So these two are the bottom rock technologies on which the entire telecom operator networks is getting reimagined, transformed, right? So SDN stands for software defined networking, to make your network now malleable, configurable, programmable networks for the different new age applications you want to run it. And NFE is network function virtualization. So rather than having the hardware and software coupled as a box, I can delineate the two. So my hardware can be general purpose hardware now. For example, it can just be an Intel server, like your laptop, right? Just more powerful. And the software can run as virtualized elements on top of them as a VM or a Kubernetes cluster, right? Again, Kubernetes cluster, the future of all IT and networking. So that's another very important area as students I would recommend you to focus, right? So SDN, NFE, and Kubernetes, right? So with this NFE now, I can decouple the hardware and software. So what does the decoupling give me? Now I can update the software for new age services. I can update the software for new application. No vendor lock-in. I can throw one vendor software out and bring another software in, just like how you install and uninstall from your laptop, right? So this SDN plus NFV now gives me a put together, gives me a complete flexible network where I can launch new services, right? So that's where you see in this slide the magic of NFV, where now you move away from these embedded boxes like your Airtel DTH to a COTS off the shelf hardware where I can run my virtualized software. So it makes it easy to install, uninstall, upgrade, remove, change the vendor, all of it, right? And SDN, it delineates the control part and the data part, so the network becomes completely programmable. So with this, I have a completely programmable network where I can launch new services. Now, the last part of the technology, right? So all of this sounds good. I have a programmable network, I can launch new services. But what's the flip side of this? The flip side of this is a lot of moving parts, right? Because before the end of the day, it in the old age networks, it used to be a bunch of embedded boxes which could be wired together, right? But now we are talking everything is softwareized, everything is virtualized. So we are talking about tons of dockers, images, configurations, data everywhere. Because when you softwareize it, we're also talking about data driven possibilities, data everywhere. So a lot of moving parts. So how do I do my management of all of this, right? So if I have a laptop, I can install and uninstall applications, pretty easy to do. But imagine a huge data center. In this huge data center, I now need to be able to manage all the software running, the configurations, the connectivity, the services. How do I manage it, right? So that's where the final concept of the day called Mano comes in. Mano is here nothing but a NFA management and orchestration layer. So this gives you the ability to manage all this different virtualized software, right? So your physical infrastructure that you see on the bottom is your data center. This gets virtual, so I can have like 100 servers. All of this, thanks to the power of virtualization, becomes a single pool of compute, right? So imagine a technology where, see, I can install software on my laptop, you can install software on your laptop. But imagine virtualization is technology where, imagine if all our 100 softwares is all pulled together. So all the CPU, memory, and RAM for each of these laptops is given a single view on which I can install applications. So that's what the virtualization does, right? So because in a data center, I'll have 30 servers, 40 servers. All of these CPUs and memories and storage is virtualized into a single entity. So I can just install and uninstall software on that. Now the management suddenly becomes easier. That's the magic that Mano brings to the table, right? So with Mano, SDN, NFV, virtualization, and Kubernetes, now I can build a fantastic system in which my network is now programmable. Our Mr. Kumar, now the CEO, is very happy because he can now launch a lot of new services does don't have to be constrained to data and voice anymore. New age services, new revenue models, new business models for the operators, better customer experience, and revenue for the operators, and hence progress overall. Right. So that's what these technologies brings to the table. So as students, I would like you to take a note of this box, which kind of consolidates all the technologies that we talked about, which drives your modern day telecom networks, right? To recap again, SDN for programmable networks, NFV for virtualized software, cloud for hosting the data center, and then orchestration to. So why is it called an orchestrator? If you see a symphony, right? If you ever seen a symphony, you'll see one guy with a stick who kind of orchestrates all the violin, the pianos. So this orchestrator software does the same thing. It orchestrates a different software and configuration across the data center, so a 4G or 5G network can be built, right? So these are key technical elements, and cloud is again now largely driven by Kubernetes. So these are all the technical areas that you need to focus if you want to work in today's modern day telecom networks. Right? Any questions on this so far? All right. So I hope that was clear. So now with this technology introduction, so now we had a technology introduction on how modern day telecom networks are being built. So this sets the stage to move to the second part of our presentation, where we are going to do. So what can we do with this technology? One part, of course, we talked about new age services like AR, VR, uh, IoT, gaming, which end consumers can like us can enjoy. But however, the power of this technology goes beyond that. With this technology, we can now drive towards digital equality, right? Because if you think about it, think of the quality of schools, education in cities versus the rural side. Even within the cities, if you compare between, say, private or a public school, but more so when you talk about urban and rural, the gap that we have in education, in healthcare, in women empowerment. So all of this now can be improved and tackled, and the so-called digital equality can be bought with this service, with this new age network. Why? Because with this new age network, in my previous presentation I told now the network is fully modifiable for new applications. From our perspective, fine, AR, VR, IoT, gaming, etc. But what that also means is I can also now construct networks with which I can offer education as a service, right? I can now have broadband education where I can do rural educations to students. I can have remote healthcare where doctors can sit in Chennai or in urban centers and do even remote surgery in rural places, right? Because my network can now offer low latency. So this is where this new age networks can offer a lot of new age social applications through which we can bridge the urban and rural divide. So this is going to be what I'm going to center my second part of my presentation. So let me go ahead and share my screen again. There you go. In fact, I'm going to be talking about this in a conference as well soon. So let's look at today's problem statement, right? So we take our 4G mobile for granted, right? We watch IPL, we Netflix, Instagram, we take it for granted. However, the world is not really like that, right? So if you look at this graph here, look at the staggering statistics. 4G and above in high income countries, 11% is the gap, right? Which means what 89% of the people in developed countries have 4G and above. However, if you come to the right side of the gap, and this is published by ITU, 99% of the people for low income is not even India. We're talking about sub-Saharan countries like Somalia, etc. Right? For 99% of the people are still in 3G and below. In fact, 20% of the people don't even have mobile connectivity. Look at the disparity, right? 11% coverage gap in high income. We India will fall more in the middle side, 99% in the low income, right? Staggering difference. So, what does this mean, right? the people in the low income countries are going to lose out on quality education, healthcare. So because when you talk about this disparity, right, if the mobile disparity is so much, imagine the disparity in education, imagine the disparity in general equality, yeah, good health, right? So that's where can we in figure out how to build these new age networks so that I can fast forward these areas that the low income countries are lacking in, so that with that I can create equal opportunity for the people in those countries. Even in India, it's true, right? The rural countries, so that ultimately I can bring in equality and wealth distribution, right? Because when can I use technology to build the awareness, to build the knowledge in the underprivileged, low income community, in the rural community, so that with that they can now start participating in the society like you and me, and so that that helps to bring out overall equality, right? Because why this is important, think of the other alternative. What's the other alternative? How long is it going to build schools all over the rural place, which are equivalent to urban? How many decades is it going to take to provide medical facilities that are equivalent in quality to the cities? But with technology, because my new age network, which I explained in my previous slide, has the ability to support these kind of digital education, digital healthcare, where I can leapfrog decades and create equality, empower them to participate in the society like the way that we can do. So that's the power of this technology from a social perspective. But having said that, so why people have not done it then, right? Because there are a variety of challenges. One is high cost. It's We talked about new age networks, but new age networks are, I mean, when you don't even have the basic infrastructure, there's going to be a lot of cost to build that network, lack of technical expertise in those kind of communities, lack of operations and security expertise. Right? So costly to build, uh, we don't have enough people to know how to build it and how to operate it, right? These are the challenges. So that's where we in Tata Elxsi have been working on a framework called Neuron, powered by open source. Of course, this is not just for the social use cases. This is also for the commercial use cases I talked about, right? Like your AR, VR, IoT. So we focus on both, right? Tata being a, as you all know, probably Tata is renowned for its altruistic capitalism, right? They're very strong on the social responsibility side. So Neuron, of course, there's a definite business angle to it, where we work on enabling new age revenue models for operators, but on the side, reuse and empower the technology for the vertical use cases for social empowerment. So let's take each of the three challenges that we saw in the previous slide: high cost, complexity of building, and complexity of operations. So this slide is going to talk about how we are going to tackle the complexity in building and operating a network which can give you these kind of digital healthcare and digital education. In the next slide, we'll talk about how to tackle the high cost, right? So this is a core technology part where telecom operators can now use next generation Gen AI modules to. So when you talk about the complexity of technical, how can I alleviate that, right? How about I get the data and then I build Gen AI models where people can communicate to it, like how we communicate to Chat GPT, and then learn how to build the network and how to operate the network. So that's going to now simplify the complexity, right? Because you have a fantastic helper hand, a Gen AI chatbot, which is going to help you through the process of build and maintenance. So that's what you see here. So providers can now, when you build these networks for meant for the social causes, you can use a Gen AI engine to give your intent, and this intent is internally broken down into engineering intent, right? Example of an intent is here. See, I want to deploy network for healthcare with 10,000 capacity in AWS cloud. So this can be a very, very big technical challenge. But now with Gen AI, I can automatically break it down into an engineering intent, from social intent to engineering intent. And then I can deploy the network Using AIML, I can maintain the network in an autonomous manner so that I don't need too many people to come in and learn how to operate it, etc. Right? Because using artificial intelligence, I can find out issues in a predictive manner, in a proactive manner, find the RCA and fix the issues so that the network is 24 bar 7 up and running. Right? And for the high cost part, so using Gen AI and the notions of autonomous using AI ML, we simplified the complex, solve the complexity problem of build and roll out. But still, the cost problem exists, right? So how do I alleviate the high cost of building this network for these kind of rural and low income countries? So that's where we are bringing a new notion called social credits. You might have heard of carbon credits, right? So you can buy carbon credits to offset the kind of the CO2 emission that your company is doing. So similarly, the network technology neuron that we are building has a concept of social credit, where companies can sponsor this network for a variety of use cases across different domains. For example, here you see uh, public, corporates, government can contribute to a variety of social credits. It can be for cloud, it can be for hardware, it can be for the spectrum, right? And it can be done across services like agriculture, education, employment, healthcare, and we have a dashboard where people can come and see where the need and necessity is, and then they can contribute to it. And how this ties up to the cost factor, with this social intent contributions, we go ahead and fine tune the network so that we can create that use case. So for example, let's say we are providing education for 1,000 engineers, right? On paper, it's education, but from networking perspective, we are talking about high bandwidth service, and we are talking about coverage, right? Now you want to increase that coverage to another 10,000 students, which may be another 20 villages. Then you can buy maybe a private 5G spectrum, or you can buy the bandwidth using the social credits. So Neuron, as a technology engine, will extend the network for those use cases in those areas, right? So that's what Neuron brings to the table. And with this, we can do a variety of use cases across the sector, healthcare, education, gender equality. Uh, it can be for entrepreneurship. I mean, you can imagine, right? So when you talk about a network, I can provide bandwidth, I can provide latency, I can provide machine to machine communication. After that, yeah, sky's the limit for your imagination in terms of what kind of use cases that you can implement to accelerate the development. Again, the beauty about digital is, going back to what I said, it's a real acceleration, right? Because the digital, if you take a simple example of an education, I can offer world class education with that bandwidth, as opposed to think about upgrading every single junior and middle school and high school in every village in India, right? Which is easier to do, right? That's the power of digital to drive equality. And we demoed this first in Barcelona. I was in Barcelona in Feb, where we demoed this neuron technology. I'll be demoing the next version in Geneva next week. Actually, I'm going to Geneva, and then we have a roadmap to go to Shanghai in July, and Delhi in October, and we are getting it standardized as well. Right. So we have a global collaboration that works on it. We have a collaboration with Taiwan, Europe, US, where we work in partnership. And this is where I encourage the students of SVC to get into it. So if any of you are interested, please reach out to me on LinkedIn. I can onboard you. Uh, where the engine of Neuron that drives a lot of this, we have open, it's part of the open source. We also contribute to it. We have contributed more than 70,000 lines of code to it. So it's that the project is called Open Source Mano that you see here. Fantastic program if you want to sharpen your Python skills, or if you want to sharpen your automation skills, which is the future of all of telecom industry, right? So encourage you to participate. If you want to participate, form a team, reach out to me, and I'll be more than happy to onboard to you, and you can start working on features which we can from the industry help you out. It will not only help you to learn telecom networks, Python programming, but also will improve your resume and your portfolio, right, as you go along with the career. Right. So with that, I conclude my presentation. So just to uh, to kind of summarize again, the telecom networks is going through a rapid transformation, digitization, software centricity, with which a lot of new age applications are possible. There's a business element to it. Operators are happy because now they can have new age revenue models from new services like IoT, AR, VR, B2B use cases like remote surgery, Industry 4.0, etc. All these again are applications. On the flip side, I can use the same exact technology to build social use cases like digital education, e-health, through which I can rapidly accelerate the empowerment of the rural side, help them build the awareness there, help them participate in the society, and help to create equal wealth distribution and then equality in society, right? So that's the power of this technology. And from students perspective, for you to get into it, from a career perspective, irrespective of whether you want to work on the neuron platform or in telecom industry in general, if that's your passion, key technologies to learn: SDN, NFV, cloud, Kubernetes, mano orchestration, and then if you want to put all these skill sets to use to build your portfolio and knowledge in a real world scenario, that's where I gave you the option of participating in open source mano, where we are very strong contributors and we would love to onboard you into that initiative, right? So with that, I'll stop my presentation. Any questions?
Yes, actually. I have a question, Ramesh. This is
Please do.
Ilango. This is Ilango. I'm from 97 ECE. And it was a great presentation, by the way,
Thank you.
and very, very intuitive. And I can see how you are very passionate with what you do. That's very cool, actually, and very inspired in a way to understand all this. This is we never saw it this way, even though we've been all using communication technology for so long. Anyway, I come to my question. So my question is, I'm trying to connect between what we see, like I'm using a phone, let's say, and I'm using Gmeet and things like that. How it actually translates into this new technology. I was assuming it's already there in a way.
Yeah, yeah.
How far we are and
Hmm.
what is the
That's a good
disconnect.
question. Good question. Very good question. So if you look at applications, right? If you, for example, Netflix, right? It's broadband, it's a video service over the network. The Google Meet that we are in. So these applications, the way they use the network is we call it over the top, right? That's why it's called OTT, right? Over the top, in the sense that the network is provided and the applications use the network to connect the customers or clients like us to their servers for the service, right? So what, in essence, to put it another way, the network is completely agnostic to what application is running on it. The network always provides you certain throughput, bandwidth, and latency. That's laid out, right? It has no, it's like a road, right? It has no idea whether the your road doesn't have an idea whether a two-wheeler is going on top of it or it's a Ferrari or a Maruti 800, because different, because they all have different requirements, right? You don't want to have speed bumps in a Ferrari, in a road where a Ferrari goes. It's going to, because they have very low road clearance and it's going to break the car, right? Maruti 800, sure, it can go on any road, but we don't need to build super fast 8 lane highways for roads because it can only go in so much speed, right? So similarly, all these applications have different requirements, but however, the current network, even though you are right, the applications are there, is completely agnostic to what the applications are running on. It always offers certain throughput, certain latency, and certain bandwidth. So, but what these technologies bring to the table is the network itself will dynamically modify itself based upon the needs of the application. So, that's advantage number one. Advantage number two is because it is software centric, from an operator perspective, now I can write applications on the network, right? So, before, the way it is you have servers, you have customers, and the network is in between. Now, I can use the capabilities, that's what we call as programmable networks. I can use the capabilities of the network. For example, let us say I'm doing an IoT application, right? The network can now expose APIs for device onboarding, device location tracking, geofencing, device IDing. So with all of this now, I can offer platforms where application developers can only need to worry about the business logic and don't have to worry about any of this connectivity or any of these other protocols. So ease of writing new application, deploying the application, fine tuning the network for the application is what the big differentiation this technology brings.
Very cool. Very cool. Thank you. I think that answers the question. Is anyone else? Any questions?
Uh, Hello, so this is Abhishek from EC department.
Yeah.
So I have an offer from Tata Elxsi. Got it back in September. So as someone who's been with Tata Elxsi for like 13 years, what would you say to people who are joining new in this company to have a good career growth? And what are your tips on that?
Sure. See, Tata Elxsi, okay, to give an introduction about Tata Elxsi, so I'll just take a broader answer at that. Tata Elxsi is part of the Tata Group as one of the software arms of Tata. There's TCS, there is there's telecommunication, there's so why Tata Elxsi, right? So Tata Elxsi is the product and solution design arm of Tata. So that's our USP. So we work with our customers from the initiation of the idea. We develop it. So we have our own products, or we develop products and turnkey solutions for our customers from ideation all the way up to deployment and maintenance. So that's we are a design house, like to put it simply. That's how we differentiate from other companies, both within and outside Tata. So that's our DNA. We are a design house where we build platforms, products, both in-house and for customers. So as you can imagine, that creates a bit of a different culture here compared to a regular IT services company because there's a lot of design thinking. When we talk about building platforms and turnkeys, there's a lot of design thinking involved, architecture, build layout. So that creates a very positive culture that is oriented towards engineering, design, and productivity, right? And of course, when you think of that kind of a culture, the hierarchy is very flat because when you talk about building these kind of design digital, right, it will not work if you're going to make it very hierarchical or fixed roles, because the next great idea can come from anybody, right? So that's our culture in Tata Elxsi. If you throw your hand up and say you want to take a crack at it, sure, you can do it. No questions asked. You're not limited by your designation on what you're allowed to do. A very open culture, a very technology oriented culture, always working on cutting edge because our DNA is on products and solutions. So, from a career perspective, you get a fantastic exposure to the latest and greatest tech, build a lot of cool software and product, and then in terms of growth, it's really your vision and take on it because there are no designation based breakup for you. For example, I have one architect in my team called Sham. He's a full fledged software product architect, but he only has 3 years of experience. Right? So that's the open culture that we have.
Thank you, sir. And as one small doubt, as I said, I got my offer back in September 2023. So, like, do you have any idea as to when will the onboarding be? Recently, they said that there would be a test to determine the date of joining, and yeah, actually, we didn't receive the material as of yet. But as far as your idea, like for 2024 batch, when will the
That you
onboarding
have
be?
to contact only the your recruitment and hiring team.
Okay, sir. Okay, I got it. Thank you, sir.
Sure.
Nice. Any other questions? Anyone? Okay. If not, I would like to thank Mr. Ramesh for such an insightful and inspiring presentation. your expertise and passion for advancing the telecom technology is truly obvious and enlightened us today with it. And we really appreciate you taking the time to share your knowledge and your expertise with us and showing us a new world out there, even though we've been so obviously using it so far. So we thank you very much, Ramesh. Thank you very
Yeah,
much.
thanks a lot, Elengo, and always fantastic to speak to SCS. Being an alumni, I'm very, very happy I got to touch base with some of our students. Thank you for hosting me today.
You're most welcome. Look forward to having more sessions with you. Thank you.
So, thank you all. Have a
Thank you,
great day.
everyone.
Thank you.
Thank you.
Thank you,
Have a
sir.
great
Thank
evening.
you.
Thank you, sir.
Yes.
Thank you.